To understand binary search trees, you only need to get a few fundamentals right. I will try and simplify this concept as much as possible. This is an introduction to binary search trees and will be the first video of Data Structures Binary Search Trees playlist. After this, you'll have a good introduction to binary search trees, or BSTs for short. And by introduction, I mean going through the definition, terminology, and the structural properties of binary search trees. And I'll be using some animation and illustrations to ensure that you see and understand these concepts. If you want a good introduction to binary search trees, let's first start by defining what is meant by a binary search tree. Welcome to Centra's Learn Fundamentals, and if you're new to the channel, welcome and please subscribe. Now, what is a binary search tree? A binary search tree is a node-based data structure. I know for someone seeing this for the first time, it's a lot, so let's break it down. First, what is a data structure? This is simply a way a computer organizes data, mainly to improve efficiency or to attain some functionality. Okay, so a binary search tree is some organized data structure, and it's organized using nodes. I will show you these nodes in a second and how they work. A node has the ability to store data and point to two other nodes. This data is stored in a tree-like structure. There is an example of how a binary search tree might look like below the definition. Those circular shapes represent the nodes and the arrows represent the pointers. But I will show you how the node is created and how it works in a moment. I want to quickly go through the terminology used when dealing with binary search trees so you can follow along easy. When it comes to binary search trees, there are a few terms you need to know. First is the root node. Now this is the highest node in the tree and it's pointing to the left and right sides of the tree. The next term is the children, which refers to the node that come under the root node and they branch out to form their own subtrees in the same tree. And finally, we have the leaf nodes. These are not pointing to any other node or subtrees, and they're usually, if not most of the time, found at the base of the tree, pointing to nothing. Okay, now that we have covered terminology, we can go through the structure of the binary search tree. To talk about the structure of binary search trees, we have to completely understand the node, as it is the building block of a binary search tree. We have touched on the node just a bit, and we have established that it can store data, an integer value for an example, and point to two other nodes in the tree which form their own subtrees. And the way to create a node is to use a class or a struct, which is used to create new data types. First, you will define an int value variable which will hold our value, and then proceed to define two pointers, the left and right pointers, and we'll go through on how we add nodes to a binary search tree in the next video. But for now, let's quickly go through the properties of binary search trees. But wait, we only talked about how you define a node using a struct, but we want to have a method that we can call and let it create a node for us to add to the tree, and have it return the address where the newly created node is stored in memory, so we can point the left or right pointer to it depending on whether the node value is greater or less than the parent node value. Okay, let's go through this method line by line. The node star is the type of our method, as it returns a pointer. And the BST : simply means that this method is called from the BST file. And yes, I'll show you these files with the code. The create node is the name of our method, and it takes in an integer, storing it in the variable value. Then we create a node pointer n which will hold the address of the newly created node. Now the new keyword allocates memory and returns the address of that allocated memory. So it will create our node we defined, and now that we have the address, we can access the value attribute and set it to the value passed in as argument, and then set the left and right pointer to null as they are currently pointing to nothing. Then finally returning the pointer to the node itself. Okay, we're almost there. Let's quickly talk about the structural properties of binary search trees. When it comes to the properties of binary search trees, we only have to go through a few things. Firstly, the value of the node added to the left pointer of the root or parent node in the tree has to be less than the value of the root node or the parent node. And the value of the node added to the right pointer of the root or parent node has to be greater than the root or parent node value. And what you get after this is that all the node values on the left pointer of the root node are less than the root node value, and all the node values on the right pointer are greater than the root node value. And in the next few videos, I'll show you how to code an entire binary search tree with most of its functionality, and do a C++ project with binary search trees just to show you how you would apply them. Now I strongly suggest you follow along with these videos so you don't miss anything or get confused. And in the next video, I'll show you how to add nodes to a binary search tree. So we'll be going through the add node function, showing you how it works, and finally showing you the code and explain it as I go on. And I'm also working on a document which will be a guide to data structures, going through the types of data structures, explaining them using illustrations, going through example code and applications of data structures. And hopefully by the time you're watching this will be linked down in the description and you can check it out. I suggest you turn on notification, as I'll upload a video letting you know when the material is ready. Now please take 10 seconds to subscribe, because I'm growing this channel and believe in free content everywhere. So please like and share this video with at least 5 people who will benefit from this video. Please leave your questions and comments in the comment section below. This is CentralEast Learn Fundamentals, and we're inspired to learn.